Hello and welcome, friends, to Live Coding with me. Today, I think it's going to be probably a little bit more of live struggling, but also that was last week. So, yeah. What we've been working on for the last little bit is a bot, an assistant that will ask you a bunch of questions, and then eventually there will be a machine learning component and then it will give you its best guess as to your dialect region, the dialect regions being ones from the United States of America in English. And all right, let me just go through and pause everything so we don't have connection issues. Last week we worked on getting Rasa set up, and as it turns out, all of my struggles were down to version mismatches. And then after the stream ended, I went and got a drink of coffee and took a deep breath, and then I updated Rasa and Rasa, and it worked fine. It was a one-line fix. I just was overwhelmed and didn't do it. Yeah. This week, I realized that we haven't added the machine learning component yet. So right now, it's not a super exciting bot to interact with. But we're going to be working on getting it to be accessible as an through Echo or through Alexa. So this is something that there's been quite a bit of discussion about on the Rasa forums. Let me just pull that up, particularly in the last couple of days. So, pop that open. Ah, that's me. So there's been quite a bit of discussion. A lot of people were working on it. And Heiko? I'm probably saying that wrong, shared this project that they've done that creates a connector for Echo. And that is this project here. And Echo is one of the Alexa devices, and you should be able to use this code to get started. And by you, I mean we. I'm going to use this code to get started. And there's also... excuse me. Oh, I see so hard the camera unfocused. And there's also a bunch of discussion on Stack Overflow and various other platforms on how to get the information, just the speech stream, out of the Alexa, so just the transcribed text, and take that and feed that into your whatever it is that you're using. For us, it will be our Rasa bot. So that's the general idea of what we're trying to do today. And there's a couple projects that we're gonna build off of. So I'm primarily going to be expanding on this Badaboomi. So that's Heiko, I'm guessing. My apologies if I'm saying that wrong. Please correct me. Echo 2 Rasa. There's also another example that Brian has shared for a bot that he's working on for a distillery that's near him that a friend of his owns. And this, I believe, is not using Alexa. This is using Lambda. And it is serverless. These are words that he said to me yesterday. So this is another implementation option that we're probably not going to be looking into today, but if that is something that you're interested in, here's an example for you. So before we get started, let's pop on over to our other view. And I've learned my lesson. I'm going to scooch it over instead of minimizing it so I can get back to it a little bit more easily. And it'll scooch me over. Ooh, there we go. So I mentioned that I got Rasa X installed and set up and everything is good to go. So let's just real quickly show you that so that you can see how the thrilling conclusion of the hour-long saga. So I should just be able to do Rasa. Nope. I can't just do Rasa X, because if I do that, I won't have an action server running. So when I make my calls to my action server, nothing will happen, and what I will get back is none. So first I need to run Rasa actions. Right, that's because it's Rasa run actions. Yeah, gotta make sure you get the words in the right order. So this should start a Rasa action server. And because we're going to be talking about endpoints today, I think it's worth pointing out that the endpoint for this is defined in the endpoints.yaml file, and it is running on localhost 5055 webhook. So this is the URL for accessing your action server. If you're running it locally, this of course could point to wherever you're hosting your action server. So now that that has been run, let's create a new terminal, and now we can launch Rasa X, and our skill should be usable because we have a server running our action. And it's opened over here, so let's get this. Localhost refused to connect. Sanic tried to use loop add signal handler, but it's not implemented on this platform. Noted. Regardless, it started just fine. So we should be able to see our models. So here's all the different models that we've trained, and you can see that the active model is not actually the most recent model that I've trained, which is okay. And I should be able to talk to my bot and also have my actions run correctly. So let's give that a try. And you can't see my cursor, so I'm going to say hi. Take a second to think about it. Yeah, so the problem that we had, sure, I'd love to take a quiz. Boop. So the problem that we had was just a version mismatch and having an old version of Rasa X. And what I did to fix it, I tweeted about it actually, so I can show you the exact line of code, was to update Rasa X and Rasa, and then it worked fine. Doop, doop, doop. And here, is the line of code. I just upgraded Rasa X with pip. So pretty straightforward. Boop, boop, boop. Okay, what do I call small bug? Technically a crustacean that's often found under logs and crawl to a little ball. Let's say peel bug. And you can see that the requested slot the requested slot bug has been filled by pill bug. And now I should get the next question in my elicitation form, and it was working earlier, so this is exciting. Yeah. Can I correct that to say, actually, I want the next lot of the elicitation form? Oh, there we go. Oop. What do you call a sweet carbonated beverage? And then it should listen for the answer to that. And I would call that soda, probably. And was that okay? And you can see that that slot is beverage and it's been filled as soda, and we have restarted the elicitation form. I think I should not have changed what that action was. I think it should have just stayed the elicitation form. I'd say pill bug still. And then how would I use the second person plural? I'd say y'all. Going to take a second to think, and then I get my you can see that I've run the detect dialect action. The slot dialect has been filled by the United States, which right now is the only value that it will be filled with. Eventually this will be done with machine learning, and then I'm told the answer is that I sound like I come from the United States. So this is the skill that's going to be so this is the where the bot sits currently, and this is what we're going to try to deploy using Alexa. Also, the chat is very quiet today. Can y'all hear me good? Or maybe it is also early/late for you, and you're just chilling and enjoying. Ooh, that's hot. Okay, so that is where we sit right now. And I'm just going to save the story and deal with it a little bit later. Goodbye. So, tried to set non-existent slot, requested slot. Make sure you add all slots to your story. Interesting. So it looks like I had some errors there with slots, and I can go back and figure out what was going on there later. But it does work. All I had to do was update it. So, what do we need to do now? We need to create a custom connector, and let's pull this back up and look through this code example. And there's a really nice README here as well, which I have previously read through. All of the Amazon Echo specific stuff, that might be a little bit small, make it a little bit bigger. All the Amazon Echo specific stuff is in Echo 2 Rasa, this folder. So what we have in here is in a init script, a config, and this is the information. So this is like the config for the Rasa all of the Rasa. It's the format of the default implementation, I guess is the word that I'm looking for. Let's have a sip of coffee. I'm having a little bit of lexical access issues today. So the policies here are what will tell Rasa core what to do. And then the pipeline here is a specific pipeline that this person has implemented. And what it does is it takes the entities and the intents returned from Alexa and then maps them onto predefined intents and entities from that have been defined for the Rasa model that can then be passed to core. But what I want to do is actually get rid of this part of the pipeline, so not to do that mapping, because what ended up happening in this particular implementation is that the entity extraction and the intent identification are coming from Alexa, and what I want is Alexa to give us to return just the content of the speech that was recognized. And then we do our entity and intent extraction ourselves, and then define, and this will be the same as this one, and then use the same Rasa core pipeline that we've been using. And then the next utterance will be passed back to Alexa, and Alexa will generate it using their text-to-speech. I had a second, I was like, what does TTS stand for? Generating their text-to-speech. So the big difference for us here is that instead of this Echo NLU mapper, what we will be doing is trying to get all of the content directly from Alexa. The difficulty there is that there used to be an Alexa intent called listen, I think. I should say, I've not worked with Alexa previously. This has just been like me researching feverishly and reading through the docs. So there used to be an intent called listen that would just take all of the text and then pass it back to you, but they deprecated that. So the way that people have been getting around this is by taking an intent that is very general and that pretty much everything would be mapped to, and having a slot, I think, having a slot that's just like all the text in that intent that then gets passed back. Yeah, so that's going to be the approach that we try, and it may or may not work, and we'll find out. So we're not going to be using this pipeline part, but we will be using the same core. So that's in the config file. The Echo domain, this is I believe that Alexa wants this. So these are the slots that Alexa can fill. And you can see this one, Amazon.number, has been defined by Amazon. So this is something where you might use Duckling instead if you are running locally. Duckling is like an entity recognition service that does numbers and dates and numbers also. I always said numbers. So what we're going to do is we're going to have a slot instead that is just the intent. And hopefully that will work. I mean, it'll work eventually. It's just going to take some work. And then we have this echoconnector.py, which is where the meat of the code is. So various imports. This is going to be served using Sanic. So it'll be a Sanic app. I will say I have worked very little with Sanic. Mostly I worked with Flask. So that's going to be another learning for me. And actually, when I was first looking into Sanic and learning more, like the first page that I got to was like, does not work for Windows. They have added Windows support, thankfully. And then a lot of stuff from Rasa, and we will probably actually be using even more things from Rasa. Async IO, inspect, channels. So this is what our endpoints will point to. I think this is like how we're going to pass the information back and forth. JSON for passing JSONs back and forth, because that's what Alexa will hand us back and also expect to be handed. Logging for knowing what happened. And then typing, so that we can do static typing and not duck typing. All right, so the functions that are in here, and I have already gone through this code, but I'm doing it again. A little bit more coffee. Oh, my mug today says, I work hard so my hedgehog can have a better life. And that was a gift from my husband. I have a hedgehog. Okay, so this returns a JSON string representation of the object. So whatever is passed in. To prevent issues with single quotation marks, these are replaced by double quotation marks if needed. Not every occurrence of a single quotation mark may be rebalanced. Okay, so if you pass in nothing, you get nothing out. And it looks like it's replacing single quotation marks with double quotation marks throughout. And we could probably just like make those lines a little bit more parallel. That's nothing. That's a cosmetic change. I might do that though. And then it will print JString, and then it will load the JString as a JSON. So it will take in something, convert it to a string, replace all the singles with doubles, and then convert that into a JSON again. Okay. And then echo connector. So this is, there's a number of connectors that are provided by Rasa. So I'm just pulling up the documents here. The docs. So custom connectors can let you create your own channel. There's also a number that are included with Rasa, and Alexa is not one of them, hence the need for a tutorial, which is what I'm working on. I should say, this is not a tutorial, this is me just figuring it out live. And these allow you to have REST endpoints to the server that the external messaging service can call to deliver messages. So we're going to define what is at each endpoint to pass to Alexa, or to open to Alexa, and then Alexa will make requests. and we'll do our stuff on our server, and then we'll send the information back. And Alexa will take the information and then do, ask the next question, whatever it is, and then get hopefully the text back with our weird intent hack. And then we'll take that text back and we'll do all of our NLU and dialogue management and pass it back, and so forth and so on. Your root plant should have at least 2 roots, health on home, and receive on the HTTP root / webhook. So we should have that in here. This is an implementation is the basis for a custom implementation of a chat front end. You can customize this to send messages to Rasa core and retrieve responses from the agent. Okay, so I think this doc string has probably not been updated from the example. All right, so class method name CLS return echo. Okay, so I guess you would use that to check if it's up, I'm guessing. And then we have a static method. What does it mean that it's async? Async. I'm just Googling stuff. Don't mind me. Method Python. All right, so because I imagine some of you might also be wondering this, coroutines declared with the async await syntax is the preferred way of writing async IO applications. For example, the following snippet of code prints hello, waits 1 second, and then prints world. Note that simply calling a coroutine will not schedule it to be executed. To actually run the coroutine, async IO provides 3 main mechanisms. Async IO.run function to run the top level entry point main function. This one. Awaiting on a coroutine. The following snippet of code will print hello after waiting for 1 second, and then print world after waiting for another 2 seconds. Another 2 seconds. So 1 second, hello, 2 more seconds, world. Okay. So, Stash says, hi, is there a recording of the last 5 parts? There is. It should be in the playlist called Livecoding on the Rasa channel. Also, I would say that part 5 you can probably skip. Because, I mean, you are absolutely free to watch it, but we spent the majority of it struggling with a problem that was actually very easy to fix. Okay, so the async functions will wait for something. In this case, they're waiting for an amount of time to pass, and then they will actually get scheduled when you say run main. So we're probably going to use this to wait for a response to do the next thing. All right. On message wrapper, so it takes in, Ryan says, oh, hey, Ryan. Async was hard for me to understand. The example that made sense to me was like one chess master playing against 10 people in a row. So you'd get like new play, and then the chess master would be like, okay, that play, and then, oh, this other play that just came in, and like, oh, this third play that just came in, would be my guess. All right, so on message wrapper, and it does not have a type. Ryan says the chess master isn't blocked while all of the other 10 people are making moves. I think this has made it make less sense to me. Let's finish reading the function and see if that provides additional clarity. Okay, so what it is expecting is callable user message awaitable none. Presumably this will come into play later on. Text, so the text that's passed in. Q, its position in the queue, the previous messages in the thing. And then sender ID text, so who sent the message. That makes sense if you have multiple users. And the collector gets the queue output channel, and the message, user message, so this function is, this might be from, okay, so this is one of the things that's implemented as a Rasa channel. Stash says, hi, thanks a lot. I'll watch these later. By the way, the masterclass is also good. Keep them coming. Oh, thank you. I'll let you to know. I will say the masterclass is much more a tutorial. This is not that. This is me figuring stuff out live. Although we do have plans in the works for more tutorial stuff. So stay tuned. One of them will be an Alexa tutorial. We'll get there. Okay, so this comes from the Rasa channel, and it gets the text that is passed in, the collector, which is the output channel queue, the sender ID, which we've passed in as text, and then the input channel, rest input dot name. So this would be at, okay, so this we would send in via the rest input. Okay, and then chill out, wait for a new message, and then await q.put done. Okay, so then wait for the queue to be done, or once it's executed, then set the queue to done. One of those two things, probably. Async def, extract sender, self-required optional text, and it will return required JSON get session user ID. Okay, so this just gets information about the sender from a JSON file that's passed into it. That makes sense. All right. No instruction pi method may be static. Extract message self-required. Okay, so these functions are just to get specific parts of the JSON, specific pieces of information from the file that we've been passed in. Is it a file? Yeah, I'm gonna call it a file. If it's not a file, y'all can let me know. Okay, so extracting sender is asynchronous, but extracting message is not. Also, I'm guessing that this should also possibly be text, if we're doing static typing. I'm not sure though, so that's something that we can look at later when we get there. And I scrolled up to look at something, and I have immediately forgotten what it is. Okay, and then we're defining stream response. So this method takes in self, on new message, callable user message, awaitable none. So that's the same as on message wrapper, text and sender ID. And then it's going to be of type callable any, awaitable none. Okay, interesting. And then an async function, stream responses any, queue is queue, which is a different queue from this one. where do we get Q from? Okay, so I think this is just, we're instantiating an empty Q. I'm pretty sure that's what that is. And then we are going to ensure future self on message wrapper on new message text Q sender ID. Okay, so I think on message wrapper, we are creating a wrapper for the new message that we're sending out. So like information about what's in it. And well, that's true. Well, what's true? Result await Q dot get. Okay, so it's going to wait for getting the next item in the queue, and the things that are in the queue are the message wrappers, because this function will put new messages into the queue with a wrapper, I think. And then this message will, well, there's things in the queue, wait until it gets one, and then if the result is done, which will happen here, if the result is done, it will finish. Otherwise, it's going to write a new line, and then it's going to wait for task, which I don't think we've defined anywhere yet. All right, and then it's going to return the stream, which is... Where did stream come from? We're on line 98. Stream response. Return stream. Oh, it's returning the function. Okay. So I'm guessing that this is going to be the same for every custom connector. This looks like it's sort of not specific to Alexa or Echo. And then we have, so far we have this on message wrapper. We have the extract sender and extract message that will get information out. And then we have the stream response, which says how we stream responses. And then we have a blueprint. And then all of this is in the blueprint. So this is where we're going to define the custom webhook. So this is the custom part of the custom connector. Sushant says, any idea how to make a chatbot voice-based? Is there any such tutorial? Yes, there are actually quite a few tutorials, just not for Alexa. Google sister Rasa. So boop boop boop. On the Rasa forum, we have this one's probably, I think this one's the most recent one that Yusta did, that shows you how to set up a Rasa assistant that will work with Google Assistant for the voice part of it. And then I believe at the bottom we have links to our other voice tutorials as well. Looks like we don't, but we do have tutorials for other open source voice integrations as well, like the Mozilla one, and then there's another one that I've forgotten the name of that is blue. Yeah, so if you're looking for a completed tutorial, I would point you to these. Right now, I'm reading somebody else's code and figuring out what they're doing. All right, so this is all in Blueprint. Self, on new message, callable username, awaitable none. And I believe on new message is on message wrapper, on new message. Is that one of the things that we have imported actually? Where does on new message come from? All right, good news. I have no idea where it comes from. That's okay. I don't think it's super important that we have a good mental model of that. And then we have a custom webhook, which is a blueprint, which I'm feeling pretty positive we have, we've imported from Sanic. So this is a Sanic thing now. All right. It is a Sanic blueprint. Scroll up, scroll up. There we go. And custom webhook dot format, type self underscore underscore name, inspect ducket module self underscore underscore name underscore underscore. Okay, so I'm just gonna assume that that is all Sanic stuff. So it looks like it's defining the format for the custom webhook. And then here we're going to say what's at the different endpoints for our different webhooks. Okay, that makes sense to me. So this one is the base home endpoint, the bottom one. So your blueprint should have at least 2 roots. So we're expecting this blueprint health on // and here it is, health, that if it's working, it should respond okay. So this is the 200, is that the code? I'm definitely a web developer. So that's the one that's required, and we are also expecting another one, receive on the HTTP route webhook. So webhook here, we should have receive, and we sure do. This is a get, this is a post, so this is just like checking, will let us check that it's up. This one will let us send stuff to the webhook, and then it will do to webhook, and it will say that it's dumping the request, and then print request as a JSON, and then it will get the information. It will wait until we get, no. Await happens after you do run. So once we've run the thing, then we will extract sender. And it looks like we don't need to get the user ID because this has been commented out. And then we will print the sender ID and the information on it. So far we have a dump of the request, the JSON of it, and then the sender ID printed out. And then the request will get the request field from the JSON, okay? And then should use stream will default to false, but could be true if the endpoint's bool arg has been set to yes rather. And if we're using the stream, then we're going to return the response from the stream as text. Otherwise, we're going to create a new collector that will collect the output channel. The output being from I think that's the output of, I don't know if this is the output of Rasa, like the Rasa server, or if that's the output of the service that's connecting to it. And then we're going to try to wait for a new message. And then when we get one, we're going to take the requirements. Request? That's probably request, not requirements. We're going to take JSON dump of the request and then the collector and sender ID. And then if it gets canceled, we'll say, oh, hey, message handling timed out. And then if we get an exception, we're going to say, oh, hey, an exception occurred. And these will all go into the logger that we've initialized up here. Okay. And then we're going to return our response. That's going to be a JSON file of the map2ecto collector.messages. So I believe that these are going to be the messages from the Rasa server. So it's the mapping to the echo that's specifically for echo. And this might be the same for everybody, because we know that every custom connector needs that endpoint to be able to be like, yeah, we're healthy, and then the webhook endpoint to be able to take requests in. Okay. So then we have this function map to echo, and it takes in the messages that come from the collector. So that's been handled on the Rasa end. And then we're going to map to echo. We're going to print our message. And then we're going to print the first message. So we're going to print all the messages and then just the first one, I guess. And then we're going to get that first one as a JSON object. Do we find that up here? Extract sender, extract message. No, it looks like we didn't. Okay. And then we're going to get the text from the message. So this looks like it's probably based on the format of the messages that the collector sends us. All right. And then we're going to print the answer. Okay. And then we're going to return. Okay. So the messages 0 is the thing that our dialog manager, Rasa Core, has decided that we should say next, and it will be selected from a few of two. Right? Between is for two. Among is for more, I don't remember. Anyway, so it's going to select the appropriate response from all of our utterances that we have defined. Figured it out. Started to make sense. And then that's what's going to be in the first slot. I'm wondering if there's a way we can do this without doing it by index, because if we change the index for some reason, then that wouldn't necessarily give us the right one anymore. I've done a lot of work with tabular data, and one of the cardinal rules is you avoid indexing, referencing by index as much as possible, and try to reference by name or something else. More stable. Okay. So the response that we're going to send to Alexa is going to have these attributes. So version 0.1, this must be the version of the skill, I'm guessing. And then session attributes, status test. So this is presumably, well, we're just testing our bot, and at some point we'd want this to be dependent on something about the user, would be my guess. And then the response, so this is presumably the information that Alexa will then pass on to the user. Output speech, type plain text, so not ASCII or not like a image or something. And then it's going to be the answer, so the utterance that Rasa Core has selected as the next utterance. And then play behavior, replace enqueued. Don't know what that means. So I'm guessing if there's like a queue of things that you might say, it's gonna become the next one instead and overwrite the previous things that you might have said next. And then reprompt, type plain text, text, answer, output speech. So reprompt, my guess would be if the, because right now this is doing the entity and intent extraction on Alexa. My guess is that the reprompt would be something that Alexa would do if the certainty of a specific entity or intent was very low. And instead, but it's still the same answer? How do they know when to reprompt? Mysterious. Because this is all exactly the same. And then should this end our session? We're going to say no, let's keep the session open, keep the conversation going, as it were. And at some point you do need to end the session, and I'm not entirely sure where that's being done. And then this is the custom webhook function. All right, and then an echo NLU mapper. This convert to Rasa, extract entities, process, print, persist. Where is map to echo being defined? Right here. Literally right here. Good job, Rachel. Okay, I see. So all of this is just to take the information that the collector returns to us, the response that returns to us, and convert it into the format that Alexa/Echo expects. Okay, that makes sense to me. And then we have this Echo NLU mapper component, which is used. Oh, it hasn't been used so far. Okay, so this must be. So this point here is all how to get information. Okay, so the receive here says what to do if we get information in, and we take that information and we put it in a wrapper, maybe? So we take that information in. If we're using the stream, then we'll add a new event to the stream. Otherwise, we will create a new collector, send the information to the collector, and then get back the echo mapped version of the information from the collector. Okay, so it's the collector that's actually interfacing between our web requests and our Rasa server. And then this echo NLU mapping maps the echo JSON to Rasa intents and entities. So this is in the case where echo is doing, or Alexa is doing, the entity extraction and the intent identification. And what we're doing is we're taking that information from the Alexa and then mapping it to intents and entities that Rasa has. And this is the bit that I'm hoping to avoid. But what does it do? So it takes in a component. Okay. Initializing, and then it's not trained, and then it's converted to entity. So this might be where we'd want to put our training if we were doing our own entity and intent extraction. And then we're converting it to Rasa. So we are taking in... Okay, so this will pass in probably a specific utterance, information on a specific utterance, and then we'll set the value to value, confidence to confidence. The entity will be echo NLU, and the extract will be echo NLU mapper, and then it will turn the entity, so this dictionary. And then to extract the entities, it will get slot value none, entity slot key. Okay, so it's just going to say with confidence 1, we think that whatever the return slot is what was in the slot, basically. And then process, retrieve the text message, pass it to the classifier, and append the prediction results to the message class. And it looks like at some point sentiment was included and has been commented out, so we can probably ignore that. And it gets the message text and loads it as a JSON and checks to see if it's a launch request, and if it is, it says, okay, we're going to greet the user. Otherwise, we're going to get the intent. So this might be where you would ask the collector for the intent instead, maybe, and then get the name of the intent, and then the slots, we'll get the slots from the JSON object that we've used, and if they're not yet none, then we will extract the entities, and then we'll print the intent name. Okay. And then persist is passed because a pre-trained model is already persisted. Okay, we spent an hour reading code, pretty much. But I think I have a better idea of what's going on here. So, that's what's in the Echo connector. What's in tools? Echo skill configuration. Okay. So this, I believe, is where you would put the Echo skill configuration. So instead of these examples, I've seen two approaches. So one approach is to create a intent and then have just like a repeating word for every possible length of the intent. So like, yes, 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 and then continuing on to have the so you have all possible lengths covered. And the other that I've seen is to have a string of very high entropy text, low entropy text. I can never remember which one's which, but basically 8 random words or however many that would never occur together. And that one I've seen people talking about having gotten working on the Rasa forums as well. So the big difference that we would have is if we had our own intent, that is just sort of everything. Then we could get rid of a lot of this because that would be covered by the Rasa end. And this is being sent to Alexa as training information, and the Alexa model is being trained using this. So we don't actually need to provide all this information. And this is the little database of different cuisines and types of feedback. So this echo skill configuration JSON will just be like one skill, or have one intent that's like ideally covers everything, and everything will be classified as that intent. And then what is returned in that intent is just the full text of the intent, is the idea. Lethal Jake says, "Hi Rachel, what is Rasa?" That's a good question. So Rasa is a company. Rasa Open Source is a open source, hence the name, framework for building conversational AI. So it has natural language understanding to extract information from unstructured text, and then it has dialogue management policy, or a selection of dialogue management policies to figure out how to reply to the conversation as it currently stands. And then Rasa X is an interface for interacting with and doing active training and human-in-the-loop training of conversational assistants. And then Rasa Enterprise is for businesses, if your business is building a conversational assistant. And those are all of the Rasa words. Hi, Robbie. Welcome. So, the echo skill configuration we are going to completely torpedo. And then I believe we should probably update the parts of the echo connector that are like, we're not doing any persistence, any pre-trained model usage, and we're not doing any training, because we do want to do both of those things, because our model will be running on the Rasa server that we'll have instead of on the Alexa service. Lethal Drake says, so we can use Rasa to create chatbots? Correct. And Robbie says, I came too early today, isn't it? No, it's been going for about an hour-ish. About. Okay, so we're looking at in here. There's also the echo model. And then represents the Rasa and Amazon Alexa needed NLU model configurations. So this is the... All right, so this is what Alexa is using to train their model. And I'm probably going to end up removing a lot of this, because we're going to be doing this on the Rasa side and not the Echo side. Oh, Robbie says, I'm kidding. Gotcha. It's hard to get tone from chat messages. And then the echo definition, import echo model. Well, I guess we do want an echo model. We want an echo model that will always identify something as having the same intent, and then return from that intent all of the text is the goal. All right, and that looks echo specific. Okay, and then what's in resource? Okay, so this looks like pictures of doing various skills on the Amazon Alexa developer portal, which is different from the AWS developer portal, which is different from other. I have not worked with the Amazon stack a whole bunch, so I'm not super duper familiar with the whole thing. But what I do know is that Alexa is separate from AWS. Okay, so the things that we're going to need to change are we're going to need to change the echo skill configuration so that we have our single uber intent that will cover everything. And then in the Echo connector, we need to not use the information. I mean, we are going to use the information we get back from Alexa, but we're going to do a lot less with it on the Alexa side. So what we're going to get back is going to be less structured, and then we're going to pass that via the connector into our Rasa instance, and then the Rasa instance will do the entity extraction and intent identification and decide what we say next, and then it'll pass back the, hey, this is what we're saying next, and then that will be passed to Alexa, and Alexa will say that and then get the information and pass it back. So basically we're just using Alexa as like a speech API, but it's going to be a little bit more complex. All right, that's the idea. It's been an hour. I found this fairly helpful. I hope you did as well. Going through and figuring out what the code is doing. I realized that I did not do a lot of coding, but now I know where it goes. And we'll see. I'm gonna work on this a little bit more today, and then on Friday, I imagine we're gonna continue to work on the Alexa integration unless I get the data I need, and hopefully we will have something pretty much ready to go. Yeah. Other things I'm thinking about, I wonder if it makes sense to have just a REST API working first so that I have like a more minimal example and then add the Echo stuff. But I probably want to do that in a fork of the project, because eventually I do want this to be a voice skill. Okay. Lethal Drake says, do you record these streams? If yes, where can I see them? I missed the earlier part of the stream. Great question. I do on the recordings are available on the Rasa YouTube channel. And I will pull that up and paste the link in Twitch. That's the word that I'm looking for. So I'm doing now. So I guess the real question we might have at the end to wrap up with sort of a conceptual thing is, why would you want to have a Rasa server running on Alexa instead of using Alexa to do all of the intent and entity stuff? Couple reasons. So one reason is if you're using multiple voice services, or you also have a text chat, ideally you want to be able to have one thing to maintain and not 6 things to maintain, and having one central model that you can use and then serve across different connectors will allow you to keep your stack more centralized. It's also more portable if you're working on something specifically on Alexa, and then Alexa changes, or AWS changes their prices, or whatever, you've committed to your Alexa model. Whereas if you decide you want to move your Rasa stuff, it's open source. You can just move it. It's fine. So those are sort of some reasons why you would want to do the NLU and then the dialogue management more on the Rasa side, as opposed to on the Alexa side. So that is going to be it for today. I hope this was helpful. I think it was definitely less struggle than there was last Friday, but also a lot of thinking and building mental models. So I will see you all on Friday, and we will probably continue with the Alexa integration, and I will work on it a little bit on my own, and I will show you what I've gotten when it comes to Friday. All right. Thank you so much for joining me, everybody. I hope you found this helpful. If you have any questions, please feel free to ask them on the Rasa forums, and I will see you on Friday. Talk to you then. Bye.